So I'm going to start with something controversial. DevOps is failing. That's right, DevOps is failing. At least that's what some people are saying. According to Gartner, 75% of DevOps initiatives aren't going to meet expectations by 2022. Now, who am I to argue with Gartner? Because I've been facing similar problems myself over the last few years. Now, maybe we can take a more positive look. If 75% of these initiatives are failing, then all of us here today, we have the opportunity to differentiate ourselves and succeed where others do not. So today in this talk, Matthew and I are going to go over some DevOps pitfalls that we've struggled with. And they're represented by these catchphrases that we have. The first, automate everything. The second, you build it, you run it. And the third, one size fits all. So I work at a company called Genesys. Genesys develops contact center and customer experience software. It's used by thousands of different organizations across the world. It's a pretty big company. We've got over 5,000 employees. And I first got involved with DevOps about 5 years ago when I was working on Genesys' interaction recording product. So the story begins around 2013. We were a small team. We were a new team. We were eager to adopt agile and continuous integration methodologies. But our primary customers were our on-premise customers. They would take our software, integrate it into their IT infrastructure, and they would operate it on a day-to-day basis. At the time, if you asked our team what DevOps was, we wouldn't really have an answer for you. We didn't know much about what it was all about. Here's a photograph of me around 5 years ago. I was carefree, laid back, and I had an awesome collection of whimsical coffee mugs. But then something happened that would change my idyllic lifestyle for the next 5 years. Our managers asked us to deliver our product, the interaction recording product, into Genesys' new cloud offering. For the next several quarters, things were very frustrating. It was difficult, as we went from a team delivering a product to one that had to work closely with operations and deliver our software in a software as a service model. Frankly, it was a real pain in the ass. And a lot of other teams were struggling as well, as were other companies. Cloud migration and cloud adoption was an issue for many. Notice who's not smiling in this picture? That's right, it's me. I guess I haven't learned to embrace DevOps by this point. Now, 2 years ago, I was in a meeting with some colleagues, and we were discussing a bottleneck and a design issue. And someone came up to me and said, I think we're skipping steps and cutting corners. Well, I responded, I don't think we're skipping steps. I don't think we're taking shortcuts. Actually, what he said was, we're taking shortcuts. I said, no, I don't think we're taking shortcuts. In fact, I think we're taking the scenic route. We're going too slowly. As my mind quickly recalled memories of family trips I took with my parents and my sister between Toronto and Montreal. And I would pray to avoid the dreaded scenic route that my dad would threaten to take us on. I really hated those scenic routes and the extra time it took to get home. There's got to be a middle way, a balanced way between cutting corners and skipping steps and doing these antiquated development processes. But DevOps doesn't give us any cookie cutter solutions. When we started our proverbial DevOps story at Genesys, we knew why we were doing DevOps. We wanted to deliver outstanding customer experiences using our new services. But we didn't know how exactly and what we needed to do to achieve that. The path forward was still a bit unknown to us. Today, Matthew and I will talk about 3 topics related to these struggles. First, how we try to automate our deployments for our legacy applications into the cloud. Second, when we ask development teams to take on more ownership and more responsibility for operating their services, but without giving them the guidance and the support they needed to be successful. And finally, we'll look to the future and look at how we can take our legacy applications and our new services towards a kind of one-size-fits-all approach. So let me start with the first point. Automation, automated testing, continuous delivery practices. They've always been associated with DevOps. And our team had a good level of maturity with respect to automated testing and continuous integration before we even started working in the cloud. But one of our earliest challenges was to automate our product deployments into the staging and production environments. This was really giving us a tough time. Automate everything was a rallying cry. It was a common refrain we would hear to emphasize the importance of eliminating the manual steps of our deployments. So let's look a little more closely at what we were trying to achieve. Manual deployments were complex. Engineers were trying to do them and making mistakes, resulting in errors. So automation was a way to improve repeatability and make things more consistent and reliable. We also wanted to reduce the time it took to deploy our solution, which was quite large and complex. We wanted customers to get onboarded more quickly and deliver our features faster. But automating the deployment of monolithic, tightly coupled, complex legacy software wasn't a quick fix. Our goal was to increase flow, yet neither the system nor its components were designed for deployability and system testability at scale. Let's look at some of the issues we were dealing with. Deeper silos by delegating to automation teams. Now, breaking down silos, that's supposed to be what dev and ops collaboration is all about. But if you have separate teams for deployment, you are creating new silos, which create barriers to effective design. And some of those the groups focus only on the aspects they have control over and neglect the other aspects. This contributed to the next point, which was lead time. Why would it increase with automation? Well, for one, the obvious thing was we had a huge amount of legacy product, and that had to be automated, so we had to write a lot of scripts to do that, and that huge amount of code has to be maintained. But in addition to that, imagine teams that are developing their product on a 3-month cycle. When they release it, it breaks the automation sometimes because another team is working on it. And then there's a huge cycle to fix it and improve and delay everything. This is further compounded by the fact that not only could your component break the deployment system, another team's component could break the system that everyone was using. And so if someone else messed something up, the whole system would be blocked and you wouldn't be able to get your stuff into production. Configuration drift happens when systems and hosts get out of sync. We know about configuration management tools like Ansible, Chef, Puppet. But when these tools, or when configuration management specifically, isn't given the same priority as getting your stuff deployed for the new customers, it can lead to even worse drift, as automation makes changes happen more rapidly, and the systems are getting out of sync even worse than they were before. So think about what I've just talked about. Do these problems sound familiar? Maybe they're issues you've seen when a large team develops and integrates into a monolithic application. Well, that's because software automation is, in principle, just like any other programming or software development. If you have poor design and poor practices, it can lead to technical debt and the same problems you would have if you were doing continuous integration with regular product development. So continuous deployment is an important goal for us and for other high-performing cloud companies. Shift left and define the necessary requirements to improve deployability and system testability, so you can increase the flow in a standard way. Think about qualities like multi-tenancy in your components, service scalability, and self-service infrastructure to help the service teams deploy. Matthew's going to give more techniques in this area and tell us how we're successful today.
Thanks, Monty. So with deployability being a quality that we want when we redesigned our deployment pipeline, we started with the immutable artifact. And this is like a machine or a container image and runs our service in a deployable environment. So rather than having to spin up our machines, configure the host with scripts, and then deploying our binary, we can deploy the configuration and the local environment along with the binary together. We have a central team that creates these base images, which provide our service teams with a starting point, as well as security patches, other dependencies, and other pre-installed monitoring agents. It's important that our service is self-contained and immutable because we want to reduce the configuration differences between our deployment environments. We don't want to be deploying different things between dev and production. Then we started using tools like AWS CloudFormation to manage and provision our infrastructure. And this is a declarative process known as infrastructure as code. This allows teams to provision resources that are under the service's responsibility, something like a table in a managed database. We also have pipeline as code as well. And the reason why we want all of this infrastructure as code is so that teams can keep this in their source control for versioning, code reviews, and other common coding practices. Finally, we have a team that provides us with consistent environments. And this allows us to move our testing earlier into the pipeline. So we can have our tests run in dev environment and be confident that we will have the same results in our production environment. This also allows us to perform automated testing and of our deployment procedures, something like blue-green, rolling, canary, etc. And all of this lets our teams take the responsibility of deploying and owning their pipeline. Now, on the topic of responsibility, this brings us to our next point, which Monty will talk a bit more about.
So guys, you may have heard about it. You build it, you run it. It's a great catchphrase. It lets us, push more responsibility to the developers and to the service teams. Isn't that a great idea? Maybe, maybe not. Well, the way this model is supposed to work is that development teams take responsibility for their service. They're accountable for the day-to-day operations of their systems. The operation works becomes embedded into their experiences, and the consequences of their code changes allow them to be incentivized to make their software easier to sustain. They get feedback directly from the customers or from working on the system and maximize agility. But when trying to make this transformation, it was common to hear a variety of concerns and resistance. Let's look at some examples. I don't have enough time to work on new features. I'm spending all my time doing operations and DevOps. Woe me. My stuff works in development, but when I put it into production, it doesn't work somehow. I followed all the proper best practices, but it's not working. Why can't a DevOps team handle this work? Why don't we get a centralized operations team, give them all this stuff to do, they can handle it successfully? Maybe that's a better approach for us. Well, I think these concerns make a lot of sense. And if I didn't hear developers asking this kind of stuff, I would be thinking that they don't really know what's about to happen. So I don't think there was anything wrong with asking these kinds of questions. And if we force this approach without care, it could lead to some interesting consequences. We might underestimate the effort required for every team to operate their software. Well, that's not a big deal. If we give impossible deadlines to developers, they'll work hard. Perpetuate a culture of blame by shifting it onto developers. Great for managers. Instead of having to figure out between multiple groups, we just blame one group. A lot nicer, isn't it? Watch frustration, fear, and uncertainty take hold of teams that fall behind. Survival of the fittest in action. Works in nature. Maybe this isn't the best way. Managers blaming development teams for failures can sometimes lead to dysfunction. Is there a better way? I think there is. Is there a clicker problem? Enabled responsibility. That's something that we're advocating. And we have infrastructure teams and related groups that help support the development teams and the service teams so that they can achieve the autonomy and the responsibility that we want them to have. Here's a vision statement from the infrastructure team. Deliver the technology that empowers Genesys to develop, test, and operate the platform. So let's look in more detail with some diagrams what the idea behind this really is. So we have these infrastructure groups that are responsible for things like platform, DevOps, architecture, and they support and provide leadership to the development teams, making them become autonomous, making them be able to do the things they need to support their services in production. We have tools that do heavy lifting, third-party tools, built-in tools, a lot of the stuff Matthew talked about, the CI/CD stuff. We have a whole bunch of tools to enable developers to be successful. And of course, developers are able to leverage our cloud platform and infrastructure providers' services to maximize operational leverage. Imagine having to do this 20 years ago. It wouldn't have been possible, but today we have tools and cloud providers that can help us achieve this. And guess what? It greatly reduces the complexity for the dev service teams by doing a lot of the heavy lifting, standardizing our ops practices. So I've just described how we use this tooling and the organizational aspect. But there's another foundation to our success, and that's our microservices strategy. It defines requirements for new software services based on loosely coupled architecture. These requirements instruct dev teams to incorporate cloud-native design. The first step is to decompose responsibilities and charter services that have well-defined and lightweight consumable interfaces. These form the contracts that enable the architecture to function successfully. Another principle is observability, supported with log management, synthetic monitoring, APM performance monitoring tools, alerting tools, so that teams can understand what's happening with their services. And if they need to recover, if there's a failure, they're able to reduce that MTTR and act as a service-centric team. We've already talked about the importance of continuous delivery, and that's a key deliverable for all the service teams. We also expect automated upgrades like blue-green upgrades and automated rollbacks. You can't be successful in the cloud without putting security as a high priority, and it's a part of all phases of our life cycle. Small agile teams can deploy and develop their finely grained services independently. They can use self-service tools, and the services are self-contained, and each has their own database if necessary. Multi-tenancy, scalability, and resilience are all other key principles of our strategy. Failure is going to happen, so you have to have patterns in your components to deal with that and be resilient. Together, these qualities define our cloud-native services and deliver an operable experience that supports the you build it, you run it approach. Matthew, why don't you give us your experience on the microservices that you've worked with?
Thanks, Monty. So I've worked on a few microservices, both on feature development, the deployment pipeline, as well as infrastructure. And one of our biggest problems early on was that we didn't have standard approaches for common problems. We were told what tools to use, but not how to use these tools. And so even though we had a bunch of cross-functional teams, we were spending a lot of effort trying to figure out how to use these tools. And this resulted in a lot of duplicate work between our teams, and that could have been better spent working on new features. So with the help of the infrastructure teams to provide us with guidance, tools to support our operations, as well as our microservice strategy, they enabled our service teams to deploy independently, operate quickly, and learn more efficiently. But the thing is, we can't apply this strategy to all of our components, and this brings us to our next topic.
So let's look a little bit into the future. We've already given you examples of how we overcame some of our struggles and succeeded in the cloud. So wouldn't the next step be to standardize our successful techniques throughout the organization? Well, this may not be a good idea in all cases. Remember that we had a large amount of legacy products, and we weren't starting from a blank slate. Now, the new architecture gives us scalable, agile, operable services. So that's great. We want more of this. But what about our legacy components? Monolithic, complex to operate. Sometimes they may have scale limits and other issues that go well beyond what we've discussed today. Well, we have several options. If we want to convert our older products to preferred designs, we can look at rewriting and refactoring them, make them cloud native, but this might have a lot of upfront development cost. We can also lift and shift, as we've discussed, take your existing components, put them in the cloud as is, but then you may have a lot of maintenance and operational work to do. Or we can make small changes, tinker, change a little bit, and try to get the low-hanging fruit and get those benefits. But rewriting our way out of this problem completely ultimately has a high cost, and it's going to take time. Time we don't have when our legacy components are still doing what they're supposed to do. Customers are happy with them. Moreover, the basic issue may never fully go away, because best-in-class design is always evolving. We want to experiment. We want to innovate. Today's cloud-native services may be tomorrow's legacy. Think about serverless, for example. Greg's going to be talking about it later today. So let's listen and see how that changes. It's okay for us to understand that things aren't going to always stay the same. I mean, it's a reality of our career, of our jobs. Another dimension of this is that we wanted to support different hosting models in our particular business. We have to support our existing on-premise products, and we have to also grow and accelerate our software as a service model. They may require different design approaches and support approaches as well. Now, there may be overhead to this extra work to handle two different ways of doing things, but that's okay if it derives business value. If it gives us something, and if customers want it, then it may be the right choice. Therefore, I believe that we can't implement a single one-size-fits-all approach for all these different situations at our company, at least not today, at least not overnight. One approach that could help a little bit is our hybrid approach, where we continue to accelerate in the cloud, and then legacy on-premise components can take advantage of that by using this hybrid model. Matthew's going to talk more about some of this stuff.
So when migrating our legacy components, one obvious strategy is to refactor and rewrite, as Monty mentioned earlier. But we can't do this right away. So we prioritize based on a few criteria. For us, what we did was we focused on the refactor being based on a requirement for our product and business objectives, or that its existing maintenance cost was simply too high. But those lower on the priority, we can still make incremental improvements to ease the operational burden. Maybe we want to start using managed databases services as opposed to managing your own database. We can also adopt good development practices, integrate with modern log management and monitoring solutions. We can even create consumable interfaces for other components to integrate with. We also still support highly regulated and on-premise environments, and so development teams will still need to work with traditional operations and IT teams. And we may even need to hire more support staff for this endeavor. But really, the focus of this is on maintainability and operability, because we want to focus on our new cloud platform. And so with a hybrid solution, we can offer cloud services to our on-premise customers. We can rapidly develop and iterate and benefit both of our cloud and our hybrid components. And I'm actually working on one of these projects right now, where we have a legacy component that is deployed to both on-premise and cloud environments. And the use case that we have is that we have a cloud service provided to us from an external vendor. And they have many alpha APIs that are offered to us, constantly changing and rapidly iterating. If we directly integrated this with our legacy component, we wouldn't be able to keep up. We just can't deploy fast enough. So what we did was we created a connector service using the modern architecture and agile methodologies. And so we can deploy, test, and integrate quickly with this external cloud service. We then expose a well-defined interface of our microservice to our legacy component. And this way, we can have a slower, more controlled integration. This abstracts that rapid iteration requirement that I was talking about earlier from a component that can't iterate rapidly. And to extend this idea, we can have any service in the cloud and develop it in a more agile way, and have our on-premise components leverage the benefits of these services with the hybrid approach. So while a one-size-fits-all use case is ideal, we can't just ignore the existing value of our legacy systems, but we also can't use this as an excuse to suppress our opportunity for future innovation.
5 years ago, we embarked on an endeavor to transform how we do development. Today, we embrace automation, we enable a DevOps culture, and we support our existing products alongside our new and modern services. So what I would like to leave you with today is the idea of balance. Balance between cost and investment, balance between innovation and imitation, and balance between agility and predictability. This is embodied by the oxymoron festina lente, symbolized here by the dolphin and anchor emblem. So thank you, everyone, for listening to our story today. We hope that you don't copy what we've done, but instead learn from our experiences and find your own shortcuts and scenic routes. The journey may be worth it. Thank you.